Hi, this is Jiajun Hu. This video is for the probability homework 11, problem 1. First, for the homework 11, problem 1, we have the stochastic process xt is real WSS with autocorrelation Rxs tau and power spectrum density S xx omega. So the first question is that show the autocorrelation is real and even. Well, in this part, because the xt is real WSS, so we got the Rxx tau is equal to the expected xt plus tau times xt. That is the basic property of the autocorrelation in the real WSS. So we got this, and this is real. So the Rxx tau is real. Next, using the autocorrelation property, that the Rxxt is equal to Rxx t plus tau t, which is according to this function. Well, this is equal to this, so according to the autocorrelation in WSS, we got this is equal to the expected value for xt times xt plus tau. So we have this and this. And as we know, for the expectation property, the xt plus tau times xt is equal to the expected of the xt times xt plus tau. That is just a simple switch for these two functions. So we got this one is equal to this one. And we know this one is equal to the Rxx t plus tau. This one is equal to this one, this autocorrelation function. So we have this function is equal to this function. So these two autocorrelation functions are equal. And the last autocorrelation function is equal to the autocorrelation of the negative tau. So we have the Rxx tau is equal to Rxx negative tau. So from this part, we have the autocorrelation is real, and for this part is equal to this part, we have the autocorrelation is real and even. So the positive tau is equal to the negative tau is the even, mean the function is even. Second, the power spectral density S xx omega. We need to show this is even. For this part, we're just using the power spectral density basic formula, that this one is equal to the integral of the autocorrelation tau times e to the negative j omega tau d tau. So for this integral, we have this part is just equal to the cosine omega tau, because, well, that's just because this two is equal. And for the autocorrelation part is even. What did I say? Yeah, I said that the e to the negative j omega tau is equal to the cosine omega tau minus j sine omega tau. So we have this formula. So for the first part, that the autocorrelation times the cosine omega tau, we know that the autocorrelation is real and even. So this part is even part. And the cosine omega tau, the cosine is just like this. So the cosine omega tau is an even function. The cosine positive omega tau is equal to the cosine negative omega tau. And for this part, the sine omega tau is a odd function. So we have this one is even times even minus the even times odd. We know the even times even is a even, and even times odd is odd. So for this part, from from negative infinity to the positive infinity, the whole part will be 0 because it's odd function. And for the even function, from the negative infinity to the positive infinity is equal to 2 times from the 0 to the infinity. So we have this step. Next, we need to figure out this part. So because the cosine omega tau is equal to the cosine negative omega tau, so we use this. And according to this, that is the SXX negative omega tau. So we got the power spectrum density SXX omega tau is equal to the power spectrum density SXX negative omega tau. So the SXX omega, the power spectrum density is even. That's it.